So let's try an example. Determine the area between this function and this function between 0 and 3. Correct to 2 decimal places. Now, correct to 2 decimal places is your hint that you don't have to be exact. So you don't need an algebraic solution. You can do this one using your graphics calculator. Now they've got a graph here, which I'll show you in a minute, but first I want to show you how you can produce this graph using your calculator so we all know what we're doing. So go to your graphics calculator and we'll put in these two functions carefully. Add graphs. The first one was e to the power of x over x plus 2. And then you press tab, which is over here on the keyboard. And then you type in the other one, which was, I've forgotten, so let me go back and look. X squared minus 1. X squared minus 1. So there's my two functions. A little bit messy at the moment, that's okay. They're going to meet again up here somewhere, but I can't see where. So if I hold, you can do all this with the middle thing here. If you press in the middle anywhere in the outside on the blanks part of the graph, you can grab it and then drag it. It's still not going to get this visible. So what you can then do is grab an axis, same way, hold the middle down until it turns into a gripping hand, and then drag the axis, and I'm zooming it. So now I've got an intersection point here and an intersection point here, and I'm starting at 0 to, I think it was 3. Let's go have a look. From 0 to 3. So I can find all these points of intersection. Menu, Analyze Graph, Intersection. Between here and here. There's the point of intersection. And let's do it again. Menu, Analyze, Intersection. Between here and here. And there's the other point of intersection. Now we're only actually going to 3. 1, 2, 3. Oh no, my scale's gone a bit funny now, so that doesn't work. I'm actually only going to x equals 3, which is here. I don't have to go all the way to 5. Okay, so I've got my point of intersection that I kind of care about. Let's go back over to the textbook. Look, they've got the same graph as we had, and they've carefully zoomed it to the point of interest. And that's my dog. Okay, so I've got my point of intersection, but how do I actually work out the integral between those two points? Well, again, I can use my graphics calculator for that. Let's try. So I want Menu, Analyze, Bounded Area. Lower bound. I wonder if I can just type 0. Yep. Upper bound was this point here, and you can actually just click on the point. And there is my area that it just calculated. So that was the first area from 0 to 3. Notice it doesn't have enough precision yet. I'm going to fix that in a minute. Now I want to go from this point out to 3, so I'm going to do the same thing again. Menu, Analyze, Bounded Area. Lower bound was this point, click on the point. Upper bound was 3, just type it, and there is my area. Okay, I really need these in more precision. Can I right click on them and change it? Precision, type value to change. I want the precision to be, doesn't matter, let's go something large. Okay, and do the same thing here. Oh, I'm right clicking on my computer. How can you do that? You want to go Control Menu, okay, to get the context menu. So what you do is you go here and you go Control Menu, but you have to do it on here. So you want to go Attributes, Precision again, get a nice large number. Okay, now I have my two values, 1.589 and 2.821. If we go back to the textbook, here are those two numbers and we add them together. And the final answer had to be to 2 decimal places, so we worked to 3 until we got to the end.